Today we're working on the factoring trinomials worksheet. If I had m squared minus 6m plus 8, and we went to factor that, we put m squared in the first box, 8 in the second, in the last, multiply those together, and I get 8m squared. And then I write down all the factor pairs for 8, 1 and 8, 2 and 4, and there aren't any more. Will one of those sets create a negative 6? If the 2 and the 4 are both negative. So negative 2m, negative 4m. What does the top row have in common? M. Then if I pull out an m, I'm left with m minus 2. And if I pull out an m from the left column, I get m minus 4. So my factors are m minus 2 and m minus 4. If it asks me to find the roots, what do I do? Set it equal to 0 and solve, and I get m equals 2 and 4. But on the factoring trinomials worksheet, all you have to do is factor and you're done. Okay? What if I had something weird like this? There's no middle term. It's called a difference of perfect squares. It's x times x and 4 times 4, and there's a subtraction in the middle. And those factor into what we call conjugates, x minus 4 and x plus 4. Okay, let's do number 1 together on this worksheet. So take a look at number 1. 8m squared minus 10m plus 3. What can you tell me about the answers here? This one has a leading coefficient of 8, which makes things a little bit harder. And at least one of the roots is going to be a fraction if it factors. Okay. So I draw the box, stick in 8m squared and 3, multiply those together, and I get 24m squared. The factors are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and 5 doesn't work. Will one of those combine to give me a negative 10? Negative 4 and negative 6. So negative 4m, negative 6m. This is a little bit tricky. What does the top row have in common? 4m. And if I pull out a 4 and an m, what's left? 2m minus 1. Do you guys see that? Anybody not understand how I got that? So I look for the biggest number that goes into 8 and 4. 2 would work, but it's not the largest one. 4 is the largest one. And how many m's do they have in common? Well, the first one has 2 and the second one has 1, so they both have at least 1. So I'm going to take out everything that they have in common. They have a 4 in common, and they have an m in common. So if I take a 4 and an m out of that, 8 is made up of 2 times 4. So if I take the 4 out, I'm left with 2. And m squared is made up of m times m. So if I take the m out, I'm left with a single m. Okay, and if I take the 4 out of there, I'm left with negative 1. And if I take the m out, I'm left with 1. So I took out the 4 and the m, and I'm left with negative 1. Now I do the same thing with the left column. What happens when I take a 2m out of negative 6m? Well, 6 is 2 times 3. So I take out the 2 and the m, and I'm left with a negative and a 3. So the factors are 2m minus 1 and 4m minus 3. Now, if it asked me to find the roots, which it's not going to in this worksheet, what would the roots be? So you would add the 1 and divide the 2. So the first one would be 1/2, and the second one we add the 3 and divide by 4, and I get 3/4. Okay. Take a look at number 13. Number 13, the bottom of the first page. 13 is a little bit different. It's not the same as number 1. We can actually make 13 a lot easier. How can we do that? Take out a 4. So 13 says 4p squared plus 4p minus 24. And everything shares a 4. So I'm going to take that 4 out. And if I take out a 4, what's left? P squared plus p minus 6. Do I need that 4? It depends. 4 is still a factor. It is still a factor. It's part of the equation. But that 4 does not affect the roots. So if the question is asking you to factor, then yes, you need the 4. If the question is asking you to find the roots, you don't need the 4. Now let's factor the remaining quadratic. P squared and negative 6. Oops. Yeah, hang on. It'll make sense. You're right. It'll make sense here in a second. Are there factors of negative 6 that add to be 1? Negative 2 and 3. So I put in negative 2p and 3p. What does the first row share? A p. If I remove a single p, then I get p minus 2. And if I take a p out of the left column, then I get p plus 3. So the answer is 4 times p minus 2 times p plus 3. So I do need the 4. It is one of the factors. This quadratic actually has 3 factors. One of them is a number, and 2 of them are binomials. Well, if it asked me to find the roots, which it didn't, the roots would be negative 3 and 2. And notice the 4 is not part of the answer in that case. So if the question says factor, you need to keep the 4. If the question says find the roots, then you can ignore the 4. In each of these problems, make sure that you check to see if anything will factor out. Some of them will, some of them won't. So look at number 28. What can you pull out of 28? 2h. Okay, now I'm not going to solve this for you, but I want to show you something. When you factor that problem, you're going to get this. 2h times some quadratic, and then you'll factor the quadratic. And let's say these are the answers. Okay. What are the roots? Now again, these are not the correct answers, so don't write these down. What would the roots be here? 4, negative 6. That takes care of this one and this one. What about that? Which would be? If we wrote equals 0 and divided by 2, I would just get 0. So that is not a quadratic. It's actually a cubic equation that hits the x-axis 3 times, and one of the x-intercepts is 0. So that can happen. All right, get to work.